At university, you learn a lot of theory, but there's almost no program where you learn hands-on building. With Elara Aerospace, you not only learn to do things in reality, but also get the confidence to realize your own project. When we started this project, we started in Fusion because it is the software that was already freely accessible for us via the education accounts that are provided through our university, which is the Technical University of Munich. The first part of the rocket that was designed might be the injector heads, which are these green things. This is how we prototype. We draw up parts very quickly, 3D print them, assemble them together, see how it looks, and even test them, trying different design iterations very, very quickly, and then coming to results that we will then print from metal. What Fusion is great for is taking people that have never used 3D software before to actually building functional parts. Fusion's generative design and simulation is great for fast results. For one, it runs in the cloud, so we can be working on our site, which is basically a field with containers on them, with just our laptops, not needing large computers or large stations. Test the new designs, calculate everything in the cloud, and then have results quite quickly that we can validate in reality. Fusion is actually great for collaboration. We're not limited to Munich. Everything we have is just in one Fusion project that every engineer that joins our team from any university in the world has access to. What we're trying to do, sending a rocket to space on this scale, is quite unheard of in an educational setting. We had so many times that, especially in the beginning, people tell us, "Hey guys, what you're doing, it's impossible, just don't do it." We can literally make anything because we got the tools and we got the right mindset to just try things.